The ladder diagram programming language is written in the form of rungs, similar to rungs on a physical ladder, that are scanned by the processor and the controller from left to right and top to bottom. Before we can begin writing logic in a ladder diagram routine, we need to know the requirements for the logic. These requirements should be stated in the form of if-then-else statements. The if part of each statement contains the conditions. The then part of each statement contains the outputs when the conditions are met, and the else part of each statement contains the outputs when the conditions are not met. Each if-then-else statement will typically be translated into a rung of ladder diagram logic. We begin the translation from logical statements to ladder diagram logic with the if part of the statement located before the first comma. This part of the statement contains the conditions, which must be translated into ladder diagram input instructions. Bit-level ladder diagram input instructions have two states, true or false, that are determined by reading the value of the associated tag or parameter. For a condition that is true when its associated tag value is a 1, choose the examine on or XIC instruction. For example, the condition if the in-feed full sensor tag equals 1 would be translated as shown here. Notice that Logix Designer instructions have both a name as well as an acronym or abbreviation. Some methods of inputting instructions in the various editors use these acronyms or abbreviations, so it can be helpful to learn them. For a condition that is true when its associated tag value is a 0, choose the examine off or XIO instruction. For example, the condition if the in-feed full sensor tag equals 0 would be translated as shown here. Sometimes the if part of a logical statement will contain multiple conditions. For AND logic, wherein multiple conditions must all be true for the overall statement to be true, place the ladder diagram instructions in line or in series with each other. For example, the conditional statement if the drive ready tag equals 1 and the start PB tag equals 1 would be translated as shown here. For OR logic, wherein any of the conditions being true makes the overall statement true, place the ladder diagram instructions on branches or in parallel with each other. For example, the conditional statement if the jog PB tag equals 1 or the start PB tag equals 1 would be translated as shown here. When the conditional instructions placed on a rung in a ladder diagram routine provide a path to the outputs, we say that there is logical continuity. Once we have the conditions translated into the ladder diagram language, we may shift our attention to the outputs found in the then-else part of the statement. Bit-level ladder diagram output instructions have two states, on or off, that are determined by whether or not the instruction has logical continuity. For an output that writes a 1 to its associated tag when it has logical continuity, but writes a 0 to its tag when it does not have logical continuity, choose the output energize or OTE instruction. For example, the output statement, then write a 1 to the motor on tag, else write a 0 to the motor on tag, would translate as shown here. Because the OTE instruction may, depending upon conditions, write a 1 or a 0 to its associated tag, you should avoid using more than one OTE instruction that writes to the same tag. When this occurs, it is called a duplicate destructive bit reference. If we click the Verify buttons, the Logix Designer application will provide a warning of the potential conflict. We can resolve the conflict by placing the second set of conditions on a branch of the first rung and then deleting the second rung altogether. For an output that writes a 1 to its associated tag when it has logical continuity, but does nothing when it does not have logical continuity, choose the output latch or OTL instruction. For example, the output statement, then write a 1 to the motor on tag, else do nothing, would translate as seen here. For an output that writes a 0 to its associated tag when it has logical continuity, but does nothing when it does not have logical continuity, choose the output unlatch, or OTU, instruction. For example, the output statement, then write a 0 to the motor on tag, else do nothing, would translate as seen here. Because the OTL can only write a 1 to its associated tag, and the OTU can only write a 0 to its associated tag, a pair of these instructions with the same associated tag are typically used to provide both behaviors. For logic wherein multiple output instructions must be turned on when logical continuity is achieved, you may place the output instructions either in series or in parallel. For example, the output, then write a 1 to the motor 01 on tag and write a 1 to the motor 02 on tag, else write a 0 to the motor 01 on tag and write a 0 to the motor 02 on tag, could be represented in ladder diagram in either of the ways shown here.